Good afternoon. Um, Today we are going to discuss section 2.6, which is kind of a deviation from what we've been talking about. Not kind of, definitely, entirely a deviation, because we are going to be discussing circles. And the rest of the stuff we've been discussing so far has been linear equations. And so this is going to be quite different from um, what we have been discussing with linear equations and linear graphs and things, but still going to be discussing graphing. And we are going to be relating a couple formulas to the circle formula. So there will be a little bit of talk of some linear type stuff, but all of this is going to kind of lead us into writing equations and graphing circles. So I've pulled up some notes for section 2.6, and we're going to jump right in here and talk about our first formula. And so the first formula is the distance formula. And the distance formula that we're discussing in this section is the distance between 2 points on the coordinate plane. So we did discuss a distance formula before, but the distance formula we discussed before was distance equals rate times time, which is the relationship among distance and a rate, typically miles per hour, and then time, again, typically in hours, but could be in, seconds or whatever the case is. This distance formula is used to find the distance between 2 points on the coordinate plane. So when we are trying to find out how far apart 2 points are, and they are not directly across from each other or on top of each other, there's no way to count and do that. So instead, we use this distance formula, which involves the coordinates for the ordered pairs for the 2 points. And so you can see it's a big long square root, and then underneath the square root we have the second x coordinate minus the first one, and then we square it. And added to that we have the second y coordinate minus the first one and square that. Now because of these two squares that we see here, we are never going to end up with a negative under our radical, which is good, because negatives under the radical get into imaginaries, and this is going to stay positive, and therefore we will always have a positive distance here. Now, there are two different ways that you're going to be asked to write this answer, okay? The first one is exact, and exact answers are simplest radical form. So that means if it's a radical that can be simplified, we want to go ahead and do that. If it is a perfect square, then the exact answer is the only answer that you will have. There won't be a decimal approximation if it's a perfect square, because the square root of 121 is 11. There's no decimal approximation for it, it just is. So if it's a radical, we want to simplify it. If it's perfect, just take the square root. The other one will come next, and it's the approximate. There we go. And the approximate solution is going to be the decimal equivalent of the radical. Now, again, if it's not a perfect square and you take the square root in the calculator, you're going to get this big, long decimal. And it's going to need to be rounded. So you're just going to round it to whatever the appropriate decimal place is based on what you're being asked. So this is going to be a decimal. And that'll come right out of the calculator. So we've got a couple examples here. And this first example is talking about finding the distance between these 2 points. We want to write our solution as an exact answer, and then we're going to approximate it to the nearest thousandth. So that's 3 decimal places. So let's see what happens when we plug into the distance formula. So we start with d equals big long square root. We take x2 minus x1. So 2 minus negative 3, and we square it. Then we take y2 minus y1 and square that. 11 minus 7 squared. All right. 2 minus negative 3 really means plus, so we're looking at a 5 squared plus 11 minus 7 is 4 squared. And then we're going to square each one of these values. So we've got the square root of 25 plus 16. Add 25 and 16 together, and we're looking at the square root of 41. And the square root of 41 is prime, so we're not going to be able to simplify that. This thing here is the exact answer. Now, if it was a different value that could actually be broken down and something come out, then we would want to go ahead and do that. But in this situation, we don't have anything that's going to come out of this because the only factors are 41 and 1, so there's nothing to come out. And I got my calculator. I was told the other day that you guys can hear all the rummaging around that I'm doing, so I apologize for that. A lot of times I have to take a drink because I lecture all day, or I have to get something or move some papers around. So I'm sorry for any of the background noise. And that being said, I just took a drink of my water, so sorry for the slurping. But I talk all day long, so my throat gets dry. So anyway, let's approximate this. And we're going to put this in the calculator. So I hit second x squared to get my radical. And I type in 41 and I hit equals. And if I'm approximating this to 3 decimal places, it's looking like 6.403 is my approximate answer. So exact answer and approximate. If you are not asked for the approximate answer, then you are not required to actually. So only put it if it asks. All right. Now, leave some of that up so you can still see it. All right, so this second one is the first time we're going to start talking about circles. So I want to put a circle over here, not in green. Let me put another circle over here in black so we can actually talk about it. And we're going to draw ourselves a circle because we need to discuss some pieces of a circle so that you guys have an idea if you don't already. Because in a circle, we're going to be dealing with several different things. Okay, so first of all, we need to talk about the line segment that goes from one side through the center to the other side, maybe if I can get this to do this, one side to the other. That's not perfect, but we'll just pretend it's nice and straight. Now it goes through the center, which is right there in the middle, and it goes from one end to the other. Now this line segment is called the diameter. And typically it's abbreviated with a lowercase d. So I'll just put a little lowercase d there. And then the second line segment I want to talk about is the line segment that goes from the center to the edge. That is terrible. From the center to the edge, that's a little bit better, of the circle. So it doesn't go all the way through, just halfway through. And that red one is called the radius, abbreviated with a lowercase r. Now, these two line segments share a special relationship. And we need to kind of understand that relationship and have it written down so that we know what it is, because it is going to come into play here several different times. So the radius is always going to be half of the length of the diameter. And the diameter is always twice the length of the radius. So if we have one but want the other one, these two formulas are going to kind of help us to find the missing piece. Which brings me to this example. This example says we have a point 0, 1 on the circle, and the center is at negative 3, 5. A point on the circle and the center. Now, if you look at what I'm doing here, a point on the circle and the center give you the length of the radius. However, they're asking for the length of the diameter. So we are not just going to be able to use the distance formula here and be done with it. If we want the diameter and we don't have the information, we're going to have to use one of these little formulas. Because this stuff here gives you the radius. But because we want the diameter, we have a little formula for that. The diameter is just twice the length of the radius. So if we can use these two pieces to find the radius, all we have to do is multiply the solution by 2. So that's what we're going to do. We're going to use our distance formula to find the radius. And we plug in again. x2 minus x1. Negative 3 minus 0 squared plus y2 minus y1. 5 minus 1 squared. And we simplify. Negative 3 minus 0 is negative 3 squared plus 5 minus 1 is 4 squared. And negative 3 squared is 9. 4 squared is 16. So we're looking at the square root of 25, which, oh, how nice for us. This one actually gives us a nice, neat integer answer, positive 5. But again, positive 5 is not our solution because positive 5 is the radius, and we want the diameter. So the formula is right here. No, right here. Diameter equals twice the radius. So we're just going to take the radius and multiply it by 2. And we get 10. So there's our diameter. Similarly, if we had the endpoints of the circle, we would be able to find the diameter. And if they asked for the radius instead, we would just divide it by 2. So we can use the relationship between these two pieces of a circle to find one or the other depending on what we're actually looking for. All right, let's talk about our second formula. Second formula here is the midpoint formula. The midpoint formula literally gives you the point directly in the middle of two other points. Now, this can be very helpful when you are trying to find the center of a circle, because it can be used to find the center if you have the endpoints of the diameter. So if it says here are the endpoints of the diameter, find the center, you're just throwing these things into the midpoint formula. And this is a pretty basic formula. It's not difficult to use. But notice what the format looks like, because it's very important that the format is correct. We are finding an ordered pair. So your solution is in parentheses with a comma in the middle, because that's the format for an ordered pair. And we want to make sure that we have this written correctly. So when we go to find the midpoint, this time we are taking the x coordinates and adding them together and dividing by 2. And then taking the y coordinates, adding them together, and also dividing by 2. It's essentially just the average of the x's and the average of the y's. So we're going to simplify this as much as possible. Now, if Hawk says it wants your answer as a fraction in simplest form, you leave it as a fraction. If it says decimals are okay, then that's fine, because these don't always divide nice. Sometimes they do and sometimes they don't. It just kind of depends. So we've got 7 plus 9, which is 16 over 2, comma, negative 2 plus 5 is 3 over 2. And 16 over 2 simplifies, so we can write that as just a positive 8. And then 3 halves does not, so you either leave it as 3 halves, or if they're okay with it, you can change it to 1.5. So it will just kind of depend on what Hawks wants. Typically, when we are dealing with the center and actually applying it to the circle formula, we would leave it as a fraction in simplest form. Most of the time, I would say we steer clear of decimals in the formula, but again, just kind of pay attention to what the instructions say for each individual question, because if they are okay with you putting decimals in there, then you can go ahead and do that if that makes you more comfortable. So we'll just have to kind of see what it says in HAWX for each one. All right, so let's kind of apply some of this stuff. Let's talk about equations of circles. So everybody knows what a circle looks like. A circle is a set of points that is a fixed distance from a center point. And this fixed distance goes all the way around the center. That fixed distance is the radius of the circle. So that's the radius. And then the center's in the middle, and it is kind of like the guide point for the entire thing. And the standard form equation of a circle is this thing right here. And I know this looks like a lot, but a bunch of the stuff in this is going to be numbers. Okay, so I'm going to rewrite it down here so I have more room, because we're going to talk about this in two different ways. So we've got x minus h squared plus y minus k squared equals r squared. Now, there are two different things that we're going to do with this formula. One thing we're going to do is write equations, and the other one we're going to do is graph the equation. So if we are writing equations, we're going to be putting information into this formula. If we are graphing, we're going to be taking information out of this formula. Now, there are still two key pieces of information that you need. First one is the center. And when we're writing equations, we're going to be finding the center, or we might be given the center, and we're going to put it into the formula here. When we put it in, we use opposite signs on both coordinates. These minuses in this formula mean opposite of. So when you go to put numbers in, you have to put in the opposite sign so that the correct sign is in there. The second thing we're going to be putting in is the radius. Now, when we put the radius into this formula, the formula says r squared, which means that whatever we have for the radius, we have to square it when we put it into this formula. So opposite signs and square the radius, because we're putting things into the formula. Now for graphing, we're pulling things out of the formula. We still need the center and the radius. And again, because we're pulling things out of this formula, and this formula has minuses in it, we are going to have to use opposite signs when we pull the numbers out. Both coordinates. Opposite signs. For the radius, this value in here, it's not going to look like something squared. It's going to just be a value. So when we pull it out, we have to account for the fact that this number is the radius being squared. So we are going to take the square root of that value. Now, sometimes it's a perfect square, which is awesome. Sometimes it is not. So we are going to need to know what the approximation is so that we can actually use it to graph. And anytime that it is not a perfect square, we're just going to have to do our best to get the number of units correct, because we're not going to be able to find the exact correct location on there. So we're just going to do our best. And if it's something like 3.7, we just go, a little bit less than 4 or a little bit more than 3.5, whatever the case is. But we just need to make sure that we're estimating appropriately when it is not a perfect square. When it is a perfect square, we're just going to count, so it'll be fine. So those are the two things that we are going to do with circles: write equations and graph equations. So let's see. Writing equations of circles. Now, every time we write an equation, we've got to have the center and the radius. Those are the two key pieces that go into the formula. If we are given one or both of them, then fantastic. If we are not given the pieces of information, then we are going to have to find whatever is missing. And to do that, we're going to use distance and midpoint formulas in some form or fashion. There are two examples on here of writing equations. So the first one does give us the center, which is awesome. We've got half of the important information. The other thing that we need is the radius. Now, luckily, because we have the center and a point on the circle, these two pieces of information give us the length of the radius. So if we use the distance formula, we will find the radius. So we go into the distance formula. x2 minus x1, 7 minus negative 3 squared. Then y2 minus y1, 0 minus 8 squared. 7 minus negative 3 actually means 7 plus 3, so we're looking at 10 squared. And 0 minus 8 is negative 8 squared. Let's simplify. 10 squared is 100. Negative 8 squared is 64. So this is the square root of 164. Now 164 simplifies, but if they don't want you to state the radius, they just want you to use it in the formula, you don't have to spend the time simplifying it. If you simplify it, when you go to put it back into the formula for the circle, you're going to have to square it, and then that means you're going to have to put everything back together again. So unless they say what is the radius in simplest radical form, don't spend the time simplifying. We're going to put this thing into the formula for the circle. So the radius is square root 164. Now, when we go to put this into the equation uses opposite signs on the center and squares the radius when we put it in. So when I go to do this, I have parentheses x. We don't use negative 3, we use plus 3, and squared, plus parenthesis y. We don't use positive 8, we use negative 8 squared, opposite sign, equals the radius, which in this case is root 164, squared. Now, this thing over here on this side, we're not going to leave like that. This is fine. Don't do anything with these two parentheses. They're supposed to look like that. X plus 3 squared plus y minus 8 squared equals the square root of 164 squared. Well, the square root and the square cancel each other out, so it's just 164. And this is your equation for your circle. So in that one, we had the center and we had enough information to find the length of the radius. In the second example here, instead of being given the center, we're given the endpoints of the diameter. Now again, we need the center and the radius. if we are given the endpoints of the diameter, then the radius, I'm sorry, not the radius, the center is the midpoint. So we can use the midpoint formula to find the center of this circle. And then for the radius, we can find the distance between the two and divide it by 2. Now, you might think to yourself, okay, we actually could go ahead and take the center in one of these points and find the distance, and that would be the radius. And yes, you could do that. But in case the midpoint has a fraction in it or something, we might not want to use it. So if that's the case, most people steer clear of using it and just use these 2 points and divide it by 2, which is fine. Either way, you're going to get the same answer. So whichever way you prefer is fine. For me, I'm going to do this distance divided by 2. So let's find each one of these pieces. Center first. We're going to use the midpoint formula. So we've got 5 plus 8 divided by 2, comma, 3 plus negative 3 divided by 2. Now we simplify. 5 plus 8 is 13 over 2. 3 plus negative 3 is 0 over 2, which is 0. I am going to leave 13 halves as a fraction this time because typically in these circle equations, they want the fractions. If it's okay with decimals, though, go ahead and change it if you like it that way. I'm just going to leave it like this for now. So there's my center, and that's the first key piece of information. Now for my radius. For the radius, I'm going to use the distance formula for these 2 points here, and then I am going to divide it by 2 at the end. So we're going into the distance formula. x2 minus x1, 8 minus 5 squared. y2 minus y1, negative 3 minus 3 squared. We're going to simplify. 8 minus 5 is 3 squared. Negative 3 minus 3 more is negative 6 squared. Don't get excited. That's not 0. And now we've got 9 plus 36, which is the square root of 45. Now, this value here, though, is the diameter. Remember, to find the radius, we're going to take that distance and divide it by 2. So I'm just going to put it over a 2 like that. Center, radius. Now we're going to put them in. X, opposite sign, is negative 13 halves squared. If one of your coordinates is 0, you don't even have to use the parentheses because you are not required to put y minus 0 squared. You can just put y squared, and the fact that there is nothing next to it indicates that it is a 0. Equals root 45 over 2 squared. Now remember, we're not going to do anything with these 2 pieces here. They're going to stay. X minus 13 halves squared plus y squared. On the other side, we are going to square each piece. The square root of 45 squared is just 45, and 2 squared is 4. And there's your final answer. So you can kind of see how we can use all of this information and the formulas for midpoint and distance to find whatever piece of info we need for the formula, and then use it to plug in and find the equation. So those are 2 examples of writing equations. Now I'm going to have to pause here for a second because I just got 3 phone calls in a row and I'm a little nervous about the fact that I got 3 phone calls in a row because that never happens. So we're going to pause here and I'm going to make a second video where I talk about graphing. Graphing equations is the last part of this. So we'll talk about graphing circles when we're given standard form and how to create standard form when we don't have it. So just give me a few minutes and I'll make a second video to cover that, and then we'll be all set for section 2.6. So just sit tight.